You know, deep beneath our feet, there's this vast ocean of molten iron and nickel, and it's constantly churning. And that motion, well, it generates an invisible shield that protects pretty much all life on Earth. This magnetic field, it stretches for thousands of kilometers out into space, and it's our first line of defense against nasty solar radiation. But what happens when that shield starts to get a little shaky? Because right now, over the South Atlantic, there's this massive area of weakness in our planetary armor. A huge dent, really. And it's not just sitting there. It's changing. It's growing. It's evolving in ways that have scientists and space agencies, well, they're paying very close attention. So let's dive in. What exactly is this cosmic pothole? And maybe more importantly, why does it matter to us right here on the ground? Okay, so this is the South Atlantic Anomaly, or the SAA for short. It's a huge region where our magnetic field is way weaker than anywhere else on the planet. And look, this isn't a brand new discovery or anything, but its behavior is what's really catching our eye. It's growing, it's drifting northwest, and now it's actually splitting into two separate weak spots. That's something we just haven't seen in the modern era. Some people have started calling it the Bermuda Triangle for satellites. And honestly, that's not a bad nickname. For our expensive, high-tech hardware that's orbiting the Earth, flying through this region is a genuinely risky trip. So, what's the real threat here? Well, that weakened shield lets high-energy particles from the sun dip much closer to Earth's surface. So when a satellite zips through this area, those particles can cause something called a single event upset. Think of it like a digital hiccup. It can corrupt data, cause a temporary glitch, or even lead to permanent damage. For big missions like the International Space Station, the operators often just shut down non-essential systems when they pass through, just to be on the safe side. Now, to really understand what's happening hundreds of miles up in the sky, we have to take a journey about 2,000 miles down, deep into the heart of our planet. So yeah, what is going on down there that's causing this weird anomaly up here? Well, the answer lies in this incredibly complex, fiery engine that generates our magnetic field in the first place. And that engine is called the geodynamo. You can basically picture it as a planet-sized electrical generator. But this process, it's not perfectly smooth or uniform. It's kind of messy. It's influenced by the tilt of Earth's magnetic axis and, as it turns out, by these absolutely massive structures buried way down at the boundary between the core and the mantle. Okay, meet the LLVPs, large, low-velocity provinces. There are two of these things, these continent-sized blobs of rock deep inside the Earth. One is under the Pacific, and the other one is under Africa. And some fascinating new research is suggesting that they are not created equal. Not at all. And here's the key difference. The one under the Pacific seems to be younger, denser, and it's constantly getting fed by recycled crust from the ocean floor. But the one under Africa? It's much older and way more stable. And scientists think that this gigantic, stable African structure is what's actually disrupting the flow of that molten iron in the core right beneath it, which ultimately creates that magnetic weak spot we see on the surface as the South Atlantic Anomaly. So to figure out if what we're seeing today is truly weird, we need to look back in time. Because the SAA might seem pretty alarming right now, but trust me, Earth's magnetic history is filled with stuff that's way more dramatic. Our planet's magnetic field is, well, it's far from stable. It is completely flipped many times. The last full-on reversal happened about 780,000 years ago. And there have been these shorter, temporary flips too, like one called the Lashams excursion about 41,000 years ago. So while that 9% weakening we've seen recently, while it's definitely significant, history shows us our planet's magnetic system can get a whole lot crazier. And yeah, this is not some neat and tidy switch from north to south. When the field decides to flip, it enters this really chaotic state. The main field kind of collapses, and you can get multiple smaller magnetic poles just popping up all over the planet before it finally gets its act together and reorganizes itself. And this is just so cool. In this amazing blend of science and art, researchers have figured out how to take the geological data from these ancient events and translate it into sound. The process is called sonification, and it gives us this kind of eerie, firsthand experience of what a collapsing magnetic field might actually sound like. Now, here is the most startling number from that ancient Lashams event. At its weakest point, the magnetic field strength plummeted to just 5% of what it is today. I mean, just imagine that. our planet's shield was almost completely down. And you can actually see the effects of this written in the geological record. We have ice cores that show levels of an isotope called beryllium-10, which gets created when cosmic rays smash into the atmosphere. They doubled during this time. This constant bombardment of radiation could have seriously damaged the ozone layer and is even linked, in some studies, to big climate shifts and the extinction of megafauna in places like Australia. So, this all brings us to the central question, right? We know the field is weakening. We see this weird anomaly growing and splitting. So, what does it all mean for us? This is where we enter the great geomagnetic debate. There are basically two main schools of thought here. On one side, you've got the consensus view. This is held by a lot of the major agencies, and they say, hey, this is all within the bounds of normal long-term fluctuations. They argue the SAA is a recurring thing and our field is still pretty strong historically speaking. But on the other side, you have some observers pointing to these anomalous trends. They argue that while the state of the field isn't critical yet, the rate of change is alarming and it looks a lot like the prelude to past events. This quote really sums up the consensus perfectly. The idea here is that paleomagnetic data, so data from ancient rocks, suggests the SAA has been a feature for millions of years, and it hasn't always led to a big reversal. In this view, what's happening now is just part of our planet's natural, kind of noisy behavior. But then you have the counterpoint, and this site focuses on the speed of the change. They argue that seeing things like reverse polarity patches, the rapid decay of the main field, and what they call an unprecedented acceleration of the North Magnetic Pole's drift, well, all of those things together could be interpreted as a preparation phase for a major geomagnetic transition. So where does all this leave us? Well, we're faced with this incredibly complex planetary process, a very real scientific debate, and an ever-increasing reliance on the very technology that's most vulnerable to it all. But it's really important to remember we have faced global atmospheric threats before. Back in the 1980s, scientists raised the alarm about a massive hole in the ozone layer, and the world listened. Through something called the Montreal Protocol, nations actually came together and they phased out over 99% of the harmful chemicals that were causing it. And today, the ozone layer is healing. It's a really powerful example of what can happen when science guides global action. The future of Earth's magnetic field is, well, it's uncertain. It might just recover and stabilize, or it might be heading for something much more dramatic. But while that scientific debate continues, one thing is crystal clear. Our planet is not a static rock. It is a living, breathing, dynamic system. And understanding its deep rhythms is no longer just some academic exercise. It's become a practical necessity for securing our technological future on a world that is always, always changing.